All right, good morning, everyone. I have 10:30, so we'll go ahead and get started. My name is Emily Holliday. I'm the president-elect for NC3ADL. I appreciate everyone joining the conference, and I hope you get some good information from it. Our first session today is an introduction to math accessibility by Joseph Polizotto from Wake Tech Community College. So Joseph, take it away.
Thanks, Emily. Good morning, everyone. It's a pleasure to be here. As Emily mentioned, I'm Joseph Polizotto. I'm an accessibility technologist at Wake Tech Community College, and this is my first NC3ADL conference, so it's a pleasure to be here and interact with all of you. As I mentioned in the Whova chat, if you're interested in getting a copy of this presentation, please go to the Whova interface and enter in the chat there for this session your email, or send me an email rather, with your name, and I will send you an email link to this PowerPoint. Thank you very much. So our topic today is math accessibility. And as we've been thinking about this morning, as we talk about the challenges of teaching online during this global pandemic, it's probably in keeping with the theme of challenges that we talk about accessible math, because math is a very difficult subject to make accessible, as some of you know. But there's also a lot of reason for hope that with this opportunity that we have to focus on technology, focus on our teaching practices, we can continue to be innovative and make strides even in the area of math accessibility. So the goal for today is to just give you an overview about what is accessible math, and hopefully you'll have a little bit more confidence about how to create accessible math yourself, or to share that information with others. So I first wanted to define our terms and talk about what is accessible math. Sometimes people will throw the word accessible out there, and it can mean a lot of different things for different people. So when I'm talking about accessible math today, I'm going to be focusing specifically on math in the online environment. So teaching online or math in documents. So for the purposes of our discussion today, accessible math is math that everyone can perceive, interact with, and explore on multiple platforms. Now you can see on my screen that I've got a math expression there, and it might appear to you that it looks just like a picture of math, but you might notice now that I'm navigating the math using my keyboard, and below the math I can see actually a caption of the math. Now this is just a picture for you all of what is possible when math is accessible. So if a student who has a disability was interacting or encountering this math in their online course, they could do the same type of thing that I'm demonstrating now. So many of you understand that math is a very complex topic, and there are many different aspects of teaching math that are important that we do with our students. We need to scaffold content. We need to teach to different learning strategies. There are lots of interesting and creative things that our disability service offices also can do to help make math more accessible, especially for students with disabilities. But for our focus today, we want to, again, talk about how to make math accessible in the online environment. So I'm specifically thinking now of faculty and those of you who are creating content for students in your classes. What can you do to create this type of accessible math? So what makes accessible math work, like the math expression that I was showing to you just a moment ago? An accessible math element has information in it, or under the hood, if you will, that makes it accessible to somebody who's using assistive technology or a keyboard. It's sort of like, if you remember when you were in grammar school or you were studying linguistics, if you ever studied grammar, and broke it down into sentences. You might remember breaking a sentence into a tree structure so that the nouns, the adjectives, the verbs all have a unique place within a structure. Math accessibility or accessible math is sort of like that. Each component of math is encoded in a way where the presentation of that math element and the meaning of it is in a document or in the web page. And the most common way that we encode that kind of information about math, its presentation and its meaning, is in a language called, or a markup language called MathML. That's how most people on the web, when they're trying to create accessible math, will encode the math. So here's a screenshot of what MathML looks like. As you can see, like I mentioned before, it's sort of like a grammar tree. In this case, though, we're representing information about math in a structure. And the information in this math code can be consumed by assistive technology or technology that students with disabilities use that allow them to know where they are in the equation or the formula, and that can speak the math out loud in a natural way. So as I mentioned, the word assistive technology is how students with disabilities often are interacting with content online or in documents. So an assistive technology program in general is the kind of program that a student who, say, is blind or has low vision or who has a learning disability might be using to zoom into the equation, to have the math read out loud, might be able to might want to explore the equation further. And these assistive technology programs, when the math is encoded in the way that I've talked about, they can understand where the students can understand where they are in the expression, and they can also know what kind of element it is. So they know the location and the meaning of the math element that they're exploring. Now, most times when we talk about the student who uses assistive technologies experience, we're thinking about them hearing the math, but it's also important to remember that some students who are blind, who read Braille, they'll be interacting with math using the Braille code that is used for conveying math content, which is called Nemeth. So math can be, when it's encoded in this way, communicated to Braille, to what's called a refreshable Braille display, so students can also know where they are in the math expression and be able to interact with it more easily. So if you haven't seen an example of what assistive technology is like a screen reader, for instance, which sometimes a blind person will use, or sometimes a sighted person will use, who just doesn't want to rely on their sight so much. This is an example of that with an accessible math document. So I'm going to play this video for a moment.
Algebra heading level 3. List with 3 items for. Simplify the following expression. 3x to the 5 power plus 8x cubed minus sine 7x squared minus sine 6x cubed 3 x to the 5 power plus 8 x cubed.
Okay, so as you can see there, the assistive technology program, in this case the screen reader, was able to pronounce the math accurately. It wasn't just gibberish. And the student, also using the assistive technology, could navigate from one element of the math to another. So you may be wondering at this point, what is the method that I can use to create accessible math in this way? Now, it's good to know that that code that I showed you earlier that has all the relationships of math elements, what I called what's called MathML, that's not the kind of code that humans normally are expected to write on their own. Most MathML code is generated by a tool. So as you can see on the screen, there's a GIF that's demonstrating just quickly an example of a docx file that's being converted to HTML in a couple of seconds via a command line tool called pandoc. And that generates automatically the MathML content in the HTML page. So on the screen here, I'm showing the Word document that's being converted in the GIF. You can see this Word document has equations that were entered using Microsoft Word. And then now I'm showing an HTML page that it was just converted quickly from that Word document. So that's just a quick example of how MathML or accessible math can be generated very quickly. Now, there are a variety of ways of creating accessible math. It's not just by using a command line tool. There's actually many different ways that you might want to approach it. And each one of these methods might work better in your situation. So I'm going to be presenting today 3 different methods that you might use to create accessible math. First is optical character recognition, or OCR. Second is math editing software. And third is LaTeX. So what is math OCR? So OCR stands for optical character recognition, and what that means is you're converting an image of text, or in this case math, to a digital representation of text or math. So a picture of math becomes digital math. This can be a very helpful tool to use when you don't already have math in an accessible format. I'll talk later about LaTeX, which could be used to convert directly to MathML. But let's say you just had a picture of math from a publisher's textbook or from an article someplace. It's just a picture of math, and you wanted to quickly get it into Microsoft Word or another format where the math is accessible. There are tools, a variety of tools now that you can use to do that. One is called Equatio, which is a popular program that can integrate into Google, Microsoft 365. It's a great tool also for students to use for learning how to do math, because there's a lot of ways for them to input math, either by speech recognition or predictive typing. And there's also a screenshot integration, so you can draw a picture on math, and I'll demonstrate that for you in a second. MathPix is another program that's out there. MathPix also allows you to screen grab pictures of math and then copy and paste the math into a Word document or a text editor. It also has an OCR version that you can use for converting whole PDFs into a Word document with multiple equations that are recognized. InfD Reader is a program that's been out for many years that many disability services offices use because it can convert also whole entire documents into accessible Word documents with OMML or math equations in them. So depending on your use case, your role at your institution, and the scale of the documents you're converting, one of these might work best for you. So let me give you an example of what math OCR looks like now, and I'll be demonstrating how to use MathPix. First, I will draw a box around the math content. Then I will use a shortcut key to paste it into my text document. In this example, I'm pasting the math as a math type equation into an MS Word document. Okay. So in the video, I was demonstrating pasting the math into a Word document, and I mentioned that I'm copying it as a math type equation. So when you use the math OCR program like MathPix or Equatio, and you copy the math into a Word document, you can actually choose whether to when you copy it as MathML into the Word document, you can paste it as a native Microsoft Word equation, where the equations look just like you inserted an equation using Microsoft Word's own equation format. Or if you are familiar with MathType, which is a very popular math editing software program, you can paste some MathML directly in Word as a MathType equation. So MathType is a very commonly used program because it integrates nicely into Microsoft Word. It also is a plugin in a lot of LMSs, and there's a lot of handy shortcuts that you can use for quickly creating math formula expressions and expressions. There are some other math editors that are out there. When I'm speaking of math editors now, I'm talking about the kinds of programs that you can use where you can click a button or use a shortcut key to quickly insert into your editor a math symbol. And MathType in particular has a lot of built-in like templates that you can quickly click on to just insert a whole math formula, and you can create commonly used equations. So it makes it really easy and fast to insert equations that way. A couple of other options other than MathType you might consider are MathMagick, which is available on the Mac OS platform. It does have a cost. It also integrates in Adobe InDesign. So if you're doing more graphic design work and you want to insert math into your Adobe InDesign files, that's another program you might look into. Mathcast is free, it's open source, and that is another tool that you might look into if you're wanting a free option. So now I'm going to demonstrate what it's like to use a math editor, and in this case I'm going to be demonstrating MathType. Here I'm using MathType in an MS Word document entitled Midterm Exam Algebra. I'm typing given the quadratic formula and then press Ctrl plus Alt plus Q to open a new inline equation. Now I'm using shortcuts to start a new fraction and enter minus b plus or minus the square root of b squared minus 4ac over 2a. Now my cursor returns to the MS Word document and I'm typing solve the following equation. Then I press Ctrl plus Alt plus Q again to open MathType. Then I'm entering 3x squared plus 2x minus 5 equals. I then close the MathType window and return to my MS Word document. Okay, so as you can see, I was able to quickly add equations into Microsoft Word using MathType. Another way that you can create accessible math, if you don't use an OCR program or you don't use an editor, is to just write directly in LaTeX. LaTeX is a typesetting system that is used by many STEM professionals to author books, to author articles. It's a way for, it also has a robust set of math mode, a math mode where you can insert all sorts of different types of math formulae or symbols. And if you understand LaTeX, it makes it really easy to quickly write math. You don't need to use an editor, and it's easier to edit math than if you have to use a GUI and correct MathML, for instance. So on the screen, I'm showing you an example of LaTeX in math mode. And when you use the math mode in LaTeX, there are what's called delimiters around the math. Delimiters are unique symbols that indicate to the LaTeX processor that the code inside these symbols are for math. So common LaTeX delimiters are $$ on either side of an inline equation, or $2 signs on either side of a display equation. So here we have on the left the LaTeX formula or math mode for LaTeX for two different math expressions. And then on the right, we see the math as being rendered in my browser as MathML. So that is another way that you can quickly author accessible math. So let me give you an example of writing math using LaTeX. Here I am authoring a LaTeX document in a popular LaTeX editor called Overleaf. With this LaTeX editor, math mode uses an escape character, / followed by an open or closed parentheses symbol. I am typing -b plus or minus the square root of b squared minus 4ac over 2a. When I'm done editing my LaTeX document, I press the compile button to see how the document will be rendered. In that example, I'm using Overleaf, which can output a LaTeX document to PDF, which is a common way that authors of LaTeX documents will export their documents for consumption. What we recommend and what we're recommending this in general for accessibility purposes is that you try to export your LaTeX documents to HTML, which makes the math more accessible and in addition makes the whole document more accessible. And I'll give you a demonstration of that later. So after understanding these three different ways in which you can insert more accessible math into your document, whether using OCR, using a math editor, or using LaTeX, we now are at a point where we need to consider, so now how are we going to share this document with our students? How are we going to share it with them in the learning management system? And so we need to focus on this the publishing stage of this process. And what I recommend for sharing accessible math with students is to use either an HTML standalone file that you can send directly to the student, upload into your LMS, or paste into the code editor in your LMS. Since HTML is a very accessible format, and it also can be opened up on many different devices by students, many platforms, doesn't require a specific type of reading system or application for the students to open, like PDF or Word. And if you're in a learning management system and you're authoring directly in there, if you don't have a document, but you want to author directly, I do recommend using LaTeX or learning LaTeX if you don't know it already, because it is a system that many learning management systems will recognize when they're rendering the math on the web page on your learning management system. And it also makes it easier for you when you're going back to edit your courses to just review the LaTeX and make those edits. So I'm going to be giving you a demonstration of the different components of a workflow that you might consider using at your institution. First, I want to give you just a generic overview of the workflow that I would recommend is first to determine what your preferred authoring environment is. Maybe you work a lot in Microsoft Word, and so you want to have a math editing tool that integrates there. Maybe you don't know LaTeX, so you might want to use an OCR program. Whatever the math authoring environment is, you can choose one of these three methods that I mentioned before for inserting the math. You could enter directly the LaTeX into the editor, you could use a math editor, or you could just copy the math code and paste it into your editor. Then I recommend converting your document to HTML or saving the math, the HTML plus the math as a course page in your LMS. So I'm going to talk more in detail about this process. So let's say your starting point is LaTeX, that you do write in LaTeX and you want to create an accessible version of that document. there are a variety of tools out there that you can use to convert a LaTeX file into accessible math. One is called Pandoc. It's a free command line tool that you can download on your computer, either PC or Mac. There's a link in this presentation, and it can convert a LaTeX file directly to HTML. Another program out there is Tech for HT. So if you're familiar with using LaTeX, you know that you have a package manager oftentimes on your machine that allows you to install various LaTeX packages. And Tech for HT is included as one of those in the Tech Live distribution, so you could install that. And if you want to directly convert a tech file to an EPUB or an ebook, there's also a package in your Tech distribution called Tech for ebook. So you can directly export to EPUB. And one thing to keep in mind when you are using LaTeX to convert directly to HTML is that it's really important that whatever the packages are that you're using in your tech file, that you have those packages installed on your computer, because as the compiler on your program on your computer is putting together the LaTeX and forming it into the HTML, it needs to find where those packages are on your computer. And if they're not there, those packages that are used in that tech file that were used to author that tech file, then there may be missing content in the resulting HTML. So this is why it's a good idea. I recommend Tech for HT, because Tech for HT, when you run the program, it will tell you if they're missing tech packages in your computer and prompt you to install them. And then you can run the conversion again and convert to HTML and make sure that all the content is there. So now I'm going to give you an example of that using Tech for HT. I'm on a PC and I'm converting directly to HTML. Here I'm converting a LaTeX document to HTML using a command line program called Make for HT. Make for HT is free and comes with your Tech Package Manager. Once I enter the Make for HT command in the command prompt, the LaTeX file is converted to HTML. When I inspect the HTML in a text editor, I can see that the math formula are written in MathML. When I open the HTML in a browser, I can see the math is displayed properly as well. I outputted the HTML with MathJax to ensure that the math is displayed properly in every browser. Some of you might be wondering, I said Tech for HT, and then in the video, it's talking about Make for HT. So they're the same program, except when you run Tech for HT program, the command that you use is Make for HT. But it's the same program that I was referencing earlier. Now, another thing you might be wondering when you watch that demo is I mentioned MathJax. So MathJax is an important concept when we think about math accessibility, because math in browsers, the kind of accessible math code that I was talking about earlier, like MathML, is not supported natively by all web browsers. So math that you encode as MathML will not display natively in Google Chrome, for instance, and only, I think at this time, like Firefox and Safari natively support MathML. So if you're using MathML in your browser, you need to make sure that your browser supports it. And that's where MathJax comes in, because MathJax, regardless of the browser's support, can take MathML. It could also take LaTeX or ASCII math, which is a different kind of notation of math, and it can render the math in an accessible way. So it can display the MathML to the browser. It also can render the math as SVG. It renders it as SVG, which makes the math reflow to the size of your screen and without degrading the quality of the picture of the math. So MathJax is a really useful way to deliver your math, to ensure that the math is going to display consistently across all browsers. So as I mentioned, so MathJax is a JavaScript library that renders the math in the browser. It can render LaTeX, MathML, or ASCII math. And to make sure that the HTML in your file is rendered via MathJax, all you would need to do is to paste a line of code in the head element of your HTML page. And I've put in the code into the slide, and then the interpreter of your browser will read that code, and then it will pull from the JavaScript library and convert all the MathML or LaTeX that might be in your HTML page and render it as SVG with MathML in the background. And this will make it accessible for a student using assistive technology. And I'll talk later about learning management systems and MathJax and how those interact. So let's talk now about Microsoft Word. So let's say that your authoring environment is not LaTeX, but Microsoft Word, and you want to create accessible math. So what you can do is create a docx file, use math type, which integrates in Word, and there's an option in the math type tab on the ribbon where you can select publish to math page. And what this does is it converts your docx file directly to HTML. And what we have on the screen now is an image of the publish to math page dialog box. And there's a place for you to enter the title of your HTML page and the name where your the file path and the name of the file that you'll be creating, the HTML file that you'll be creating. So you'll enter those two things. And then there's an option below in the equations group called MathML using, and you'll select HTML plus MathJax. And this will ensure, like I was mentioning before, that your HTML page has a call to the MathJax library in your document, so you don't need to add it manually. So let me give you an example of that now. Here I'm converting a Microsoft Word document that has math type equations to HTML. Using the math type add-in, I will go to the Publish group and click on Publish to Math page. Then I will enter the title of the HTML document and the location where it will be saved. I will also select HTML plus MathJax. When the process is complete, I will check the HTML in a browser. I see that the math is rendered using MathJax. If I check the HTML in a text editor, I also see that the math formula are encoded as MathML. Okay, so let's talk about learning management systems. So regardless of which LMS you use, you want to find out whether your math or your learning management system supports MathJax if it's built into the LMS. Many LMSs do now have what you could say is built-in MathJax, so that you don't have to manually type in the head of your HTML page, the path to the JavaScript library for MathJax. And if you're not sure if your LMS supports MathJax or has built-in MathJax, what you can try to do is in your text editor, either your text editor or your math editor, just paste in the LaTeX code that I have here on this slide. And you should see when you click save or submit to display your course page, you should see the math being rendered as SVG. And you should be able to right click and see the MathJax menu. If you don't see the correct display of the math and you just see the LaTeX code, then that means that your browser, or I'm sorry, the LMS doesn't have built-in MathJax. But that doesn't necessarily mean that your course page that you just created or your HTML file that your course page can't use MathJax. It might just mean that you have to add the MathJax code that I mentioned earlier in the head of your document. If trying to enter the MathJax code in the head of your document still doesn't work, you might also try changing the type of delimiters that you use in math mode in LaTeX. So if you've used LaTeX to paste your math in the editor using like dollar signs, for instance, for inline display equations, you could try the backslash parentheses symbols instead as math delimiters, and that might be what your LMS's MathJax instance is using to parse the math. And when all else fails, if your MathJax is attempts to add MathJax in the head of the document, or their LMS is not displaying the math properly, you could always upload a standalone HTML file and attach that to your course. And this could also be really helpful. This could also still be really helpful for students. So here we have an example. This is a screenshot of a standalone HTML file in Canvas where I've authored using Microsoft Word, and I converted directly to HTML, and it's rendered via MathJax. And it's displaying in the preview window in Canvas. Here I'm on a course page in Canvas, and Canvas also has built-in MathJax support, so I don't need to add the MathJax path to the MathJax JavaScript library in the head of the HTML editor. I just type directly LaTeX into my editor and then click save, and the math displays properly. So let me give you an example of a workflow with Blackboard, since Blackboard is slightly different in that it doesn't have, at least in my instance at my institution, the built-in support for MathJax. So what I'm going to be demonstrating here is the entering of the MathJax JavaScript code in the HTML source code. And in my instance of Blackboard, I need to use the version 2.7 of MathJax in the head, which I have pasted here. And then I'm going to enter LaTeX directly in the text editor area of Blackboard. And we'll see what that looks like after I'm done. In Blackboard, I will open the source code editor and insert the JavaScript code for MathJax. Blackboard currently supports MathJax version 2.7, not version 3. I then return to the text editor and insert LaTeX for my math formula. When I save the page, I can see that the math is rendered properly. While there is a math editor in Blackboard, it currently does not output fully accessible math. So when I say it doesn't support fully accessible math, when you use the math editor in Blackboard using the graphical user interface to insert math, it's currently outputting just the pictures of math with alternative text of the math. And that is not as accessible for somebody using assistive technology as it would be if the math is rendered via MathJax. So that's what I meant by that. Let's talk about Canvas. So if you're using Canvas at your institution, this is an instance where the graphical user interface does output directly LaTeX after you use it, and it has MathJax rendering automatically or built in, so you don't have to add that to the head code. You can also just insert LaTeX directly into the math editor, and it will process it properly. So let's take a look at that. So that's something that just take a step back. So when you use Canvas, those are one of the two methods that you could use. Just use the GUI or copy and paste LaTeX directly into the editor. In this next video, what I'm going to be demonstrating is another method that you could potentially use if you are using Canvas of directly exporting your Word documents into your Canvas course page, into your Canvas course, either as a course page or into the files area. And this is a method that I used in my previous role where I worked in disability services, and we were converting mini files to HTML for students, and we used Canvas. So rather than go directly into the student's course and paste the files there for that student who we were working with, we could just get the course number for the class, and we could directly from the command line send the HTML file that we were converting directly into the course. So it made it a much faster process. So let me show you how that that works. And this is using a bash script that I created that you can access on GitHub. Here I am demonstrating how to convert a docx file to HTML using a bash script called docx-html. With this script, I can also upload the HTML file directly to a Canvas course. As you can see, this Microsoft Word document has many math equations written in Office Math format. To use the script, I first open a command prompt screen from the location where my docx file is located. Then I type the name of the script, docx-html.sh, and use the -u option for upload. At the prompt, I enter the course number for the Canvas class. I then type the number 2 to indicate that I want to upload the HTML file to the files area of the course. I type same to indicate that the HTML file should be placed in a folder with the same name as the docx. When the script is done converting the file, I can see whether there are any errors or warnings about the HTML. The resulting HTML file will be located in a file on my computer with the same name as the docx. If I refresh my browser screen, I also see that the HTML file has been added to the files area in my course. I can see that the math is displayed properly in Canvas's preview screen and has a green background, which is the color property I have added in my CSS file for math. Now I will show the same process of converting a file to HTML, but this time I will upload the file as a course page in Canvas. When prompted by the script, I will press 1 to upload the file as a course page. When the script is finished processing, I will refresh my browser screen again. When I open the course page, I can see that the math is displayed properly and it is being rendered by MathJax version 2.7. I should mention that if you are going to use this docx HTML script that I just demonstrated here, again, you can go to GitHub and download the program, the script there, and there are some dependencies like pandoc that you'll need to install on your computer, either on a PC or a Mac. But there's also, it's also necessary if you want to use this upload feature that I demonstrated, that you have a copy of your API token, which all Canvas users, if you use Canvas, have access to. So you can go to your user account settings and access your API token. So let's talk now just about Moodle and how you could create accessible math in Moodle. So Moodle is nicely, it's one of those LMSs that has a lot of robust support for LaTeX. So there's a lot of different methods that you can use to insert math into your course page and have the math displayed properly. So you can copy and paste directly in the text editor or into the math editor. And I've tested with different kinds of delimiters, $ or backslash parentheses, and both of the delimiters will work for LaTeX math mode. So on the screen, I have a picture of the Moodle toolbar, and there's an equation editor button there. And you can click on that and directly insert your LaTeX if you want. And let's see an example of this. Here I'm adding math equations into a Moodle course. Moodle provides authors with multiple ways of inserting math content. One way is to paste the LaTeX directly into the text editor. I can insert LaTeX with different types of delimiters, such as $ or parentheses. Another way is to insert math using the math editor. Here I can type the LaTeX directly or use the GUI interface. When I save my edits, I see that the math is displayed properly and is rendered by MathJax 3. Okay, so those were that's an overview of a variety of workflows that you could follow for creating accessible math. I'd like to mention now another aspect of accessible math, and that has to do with graphics. So if you are working in a course where you have a lot of graphs, one of the ways that you could make your graphs more accessible is to use the Desmos online graphics calculator, which enables the graphs to be navigable to someone using a screen reader, such that they could hear the different parts or plots, points on a graph, and be able to hear the sound of that the graph makes. And so on the screen, I have an example of a graph that is being rendered via Desmos. Desmos has a free online graphic calculator. You can click on the link there and enter the formula for your graphic expression. And then once it's rendered on the page, there's a shortcut key. You can press Alt plus T, which opens up the Explorer menu. And one of the options there is to hear the graph. And all of this menu is accessible to somebody using a screen reader. And so I'm going to press H to be able to hear the graph, and you'll hear the sonification that this graph makes. And I can also use the arrow keys to navigate from one point on the graph to another. So Desmos is a neat tool that you might look into. Also, I should mention that Desmos and the graphic calculator also has an integration with Equatio, if you're interested in that program that I mentioned earlier. So let's talk just briefly, we have about 3 minutes left, about other formats that you might be thinking about in regards to accessible math. If you're delivering PowerPoint content to students and you want the math to be accessible, at this time, the best way to render that math accessibly is to use math type in PowerPoint. Then the screen reader users can get to the math and be able to hear the math read out loud properly. If you don't have math type, another way that you could author the math in that context is to have the math as an image and then write alternative text for the math. EPUB is is an eminently accessible format, including accessible math. So if you want to export to EPUB, let's say you have a large handbook, or maybe it's a course catalog for your institution, you want the math in that document, maybe for your math department to be fully accessible. EPUB is a great format for that. There's a tool called Word to EPUB that you can install that will be added to your Microsoft Word program, and then you can directly export to EPUB from there. And any Office math equations will be exported to MathML in the EPUB. And then the EPUB could be read by a reading system like Thorium Reader, which will read out loud, which renders the MathML as by MathJax, and screen reader users can read it. PDF does not support MathML at this time, so the best method to make math more accessible in a PDF context is to have an image of math plus alternative text. That bash script that I was showing you earlier that we used at my previous institution, it does have a method for you to output another version of your Word document that you're converting, where it has automatically adds alternative text, descriptive alternative text to the images. MP3 is another option there that you could use, where the math is read out loud via MP3. There's some tools out there like Central Access Reader, or another script I created called DocX MP3 that will output MP3s. Microsoft Word can also read out loud math equations that are in Office math format, the native equation editor, if you just use the immersive reader tool. So you might try that out. Google Docs and LibreOffice can be used for authoring math, but it wouldn't be the best end format to share with students, as assistive technology doesn't read the math equations in that context correctly, unless you're using a program like TextHelp or Read and Write by TextHelp, which can read Google Docs that have math content. A couple more things. Just lastly, I'd mention is some conversion tools that you might be interested in. GrindEQ is a great tool to use if you want to convert office math equations to math type, math type equations to office math. This can be really helpful, or if you want to open up a LaTeX file directly in Microsoft Word, GrindEQ can help you with that. And Pandoc is a command line tool that allows you to convert many kinds of formats into HTML or EPUB or Microsoft Word, which can be a very handy tool. I've given some resources here that you might want to look into. One is an online course at the California Community Colleges that have, it's an open source set of resources that you could look at for how to author accessible math. And then if you're getting started with LaTeX, here's some resources. And then I have a glossary that you can refer to with all of these terms. So with that, I'm going to stop here, and I realize we're at the end of our time. So I'll open it up briefly if any of you have questions. Otherwise, just send me an email and I'd be happy to follow up with you outside of the conference as well. Thank you very much for your attention.